the dog days are over. You know what that means? Means we are on to some bigger and better things, so buckle your chin straps. Welcome to the Johnson Kendra Video Hour.
But it's not an hour.
Yeah, baby. All right, polynomial fun cushions. Don't you forget the fun part because it is fun, fun, fun. All right, we have to learn some terms here before we start the math. First one is monomial. Mono means one. So it's an expression that is a real number, so no imaginary stuff. It can be a variable or a real number and a variable put together by multiplication. And here are some examples like the number 3, the letter y, 3y, or even 4x squared. See, there's no pluses or minuses in there. Next is a polynomial. Poly means many. So, polynomials is a monomial or a sum or difference of monomials. So, let's look at examples like 2x cubed minus 5x squared minus 2x plus 5. There are 4 different monomials put together. That makes a big honkin' polynomial. Now, what does it mean to have standard form? Standard form, so we all write it the same way, as when you go down in value for each exponent. So you start with your highest exponent and you work your way down to the lowest. So highest to lowest. So you can see we have 3, then the green is 2, then the blue is actually 1, and the 5 doesn't have any exponent.
Because it's 0, and we'll talk about that later.
Yeah, we will. X to the 0. All right. The first number in the polynomial is called the leading coefficient. It's like if you're in the play, you are the lead. You are the big, honkin', important one. So here it is the 2. That's called our leading coefficient.
And we're going to need that later on, so it's important that you know how to find that leading coefficient.
Right. They all have coefficients. All the numbers in front are coefficients, but the leading one is important.
It's special.
It's very special. All right, classifying polynomials. We do it a couple different ways. Let's get rid of this thing here. Okay. First, we do it by the number of terms. So, if you have one term, it's called a monomial. If you have 2 terms, it's a binomial. Oops. And then 3 terms is trinomial. And 4 terms is polynomial with 4 terms. They don't have a special name for that one.
5 terms would be
a polynomial with 5 terms. So,
polynomial with 6 terms.
Yep, everything above it doesn't have a special name. The other way to name polynomials is by degree. Now, degree is basically the exponent. AKA means also known as. So, if we have x to the 5th, it's the 5th degree polynomial. So, here are some special names for them. Polynomials with just first degree, just plain old x, is a linear. With the second degree is quadratic, which we've done a lot of those, like parabola. Third degree is cubic. Fourth degree is quartic. Fifth degree is quintic. And sixth degree, we don't have any special names anymore. We just say 6th degree polynomial. You know, when I was growing up and I heard quartic and quintic, I thought those would be good names to name my goldfish when I got them. So I did. So I had quartic and quintic. So here's an example. 7x minus 3x squared plus 2. So what are we going to name that? Let's name it with both. First of all, how many terms do we have? I see 1, 2, 3. But they're not in the right order. Let's put it in standard form first. So highest exponent is x squared. So negative 3x squared plus 7x plus 2. All right, so that's standard form. Cool. Now, how are we going to name this? We can name it by number of terms. So there are 3. So we call it trinomial. All right. And then we can name it by the highest exponent there. It's 2. And that is a quadratic, not quartic, quadratic trinomial. So it has 2 different names. Kind of like you, Ms. Johnson, Ms. and Johnson. All right, let's try another one. Is this one in standard form? Are you going from highest to lowest? Yes. Are we missing a couple exponents? Yeah, we're missing the 4 and the 2, but that's okay. They're still in order. So this is a 5th degree, but it's got a fancy name called quintic. And It's got how many terms? 1, 2, 3, 4. So we say it is a polynomial degree 4.
Not degree.
Not degree, with 4 terms. My bad. All right. All right, we got to write this in standard form. Now, you got to simplify before you even start. So 4x minus 6x, those can go together and get negative 2x. And then plus 5. So, we have two terms. That's called a binomial. And the highest degree is a little 1. It's not there. It's hidden. But we just call that linear. It's like it's a line. Like y equals mx plus b. Okay, the next one is it's simplified. No, I see some powers of 4 that can go together. 3 and 2 makes 5x to the 4th.
Not x to the 8th?
No, you're just adding how many x to the 4ths do we have? We have 3 there and 2 there. All right, next is x squared. There's only the 1, and then minus 4x is done. So we have 3 terms. That's called a trinomial. And then it's the power of 4. So we call that quartic. Nice. Quartic was bigger than quintic. He ate more food. The next one, 6 minus 2x to the 5th. It is not in the correct order. Let's switch them around. Negative 2x to the 5th plus 6. All right, highest degree is 5, so they call that quintic. And 2 terms, so it's binomial. Very nice. All right. Okay, we have the general shapes of the graphs. We have graphs that have turning points. What you have to do is realize that the number of turning points determines, is the maximum number of turning points is 1 less than the degree. So if I have x to the 5th power, it's going to have at the most 4 turning points. Okay, so if I have, let's look at this graph right here. If I go up, and down, something like that. How many turning points do I have? Here's 1,
2, 3.
So what is the highest power that this could be?
4.
Y equals x to the 4th, and then it would have, other things after it. It doesn't necessarily mean it is 4, but the highest it could be is 4. Now, x to the 5th can have 4 turning points, so I would have to add on to this another turning point. So there it makes my 4th one. So it just depends. You got to look at it and see how many turning points you have by the exponent, and that's of the leading coefficient, or the leading term, the highest power.
Basically, our goal here, we're just exploring the general shapes of graphs. We're going to go into, in the future, how to make more detailed sketch, but we're talking about turning points and then end behavior today, which is the next topic.
Right. Just trying to get a decent little sketch of these. Not perfect.
So what the end behavior does, it's telling us what the beginning and the end of the graph do. When we have graph lines, they can start low and end up high, or they could go the other way. So we're talking about the beginning and the end behavior. We've done quadratics. They either both go up or both go down. If you were to graph a cubic function, they're going to look like this, or maybe go the other way. And if you start to graph those things, you'll notice some patterns. So we need actually 2 things to determine what the end behavior does. We need to know the leading coefficient, and we talked about that on the first page, and then the degree, remember that is the exponent. So the leading coefficient is the first number in your polynomial, x to the whatever. It's this number out in front. And then the degree is the exponent of that thing out there. So we notice some patterns. If we have a leading coefficient, it is either going to be positive or it's going to be negative. And if it is positive, it means the right end of the graph is going to rise. It's going to go up. And if it is negative, if it's a negative number out in front, it means our graph falls to the right. And if you think about the parabolas that we've been working with, that makes sense according to both of those. So that tells us about the end, but what about the beginning behavior of the graph? This has to do whether it's even or odd, so you're talking about the exponent. If the degree is even, then the beginning and the end behavior do the same thing. So that means the beginning and the end both go up, they both go down. And yes, there will be stuff that's happening in between those two things, but this just helps us determine the ends. And then the exact opposite would be if it's an odd degree, the beginning and the end behavior do different things. So let's talk about some situations that you might have. So you might want to get that chart copied into your notes so you can refer back to that. We have a couple different things that could happen. We could have a positive leading coefficient. That would mean that our graph would end up. And if we had a even degree, for instance, that means that the other end would also go up. So that could represent something like x squared, or x to the fourth, or x to the sixth, etc., with positive numbers out in front. Okay? Another example would be a leading coefficient that is negative and has an even degree. So the fact that it is negative would mean that it falls to the right, and the fact that the degree is even means they must do the same thing again. So this time they're both down. And remember, that could be a negative x squared. That makes sense. That's what we've been working with. X to the fourth, negative x to the sixth, etc. Those would all look like that. How about if our leading coefficient was positive, but our degree was odd? That would be positive means ends up. Odd means does different things. So since one of them is up, the other is down. So think about your lines or our cubic graphs. Okay, so this will be something positive x to the first, or positive x to the third, positive x to the fifth, etc. Okay, and then our last possible instance would be a leading coefficient that is negative and the degree is odd. So what that would mean, negative leading coefficient means ends down. Remember, odd behavior means that they're odd, they're different. Okay, it's going to look something like that. This would be if we had a negative x to the third or a negative x to the first, etc.
All right. So odd is different, even is the same.
Positive is up, negative is down. So now that you have that information, here's what your questions are going to look like in class. They'll ask you to determine the end behavior and they'll give you an equation. So you always want to make sure you have standard form and it's simplified. And remember, the two important things are the leading coefficient. So my leading coefficient is this number out in front, and you have to ask yourself, is that positive or negative? It is positive. The degree is, remember the exponent, it's a 3, but what we care about is it even or is it odd? It is odd. So you think about how we've categorized that. Positive means that it's going to end up, but we want to talk about going from left to right. Odd behavior means that they do different things. So it will start down and end up. So something's going on in between, but it's going to end up.
Gotcha.
Okay,
so when they say end behavior, they mean front and back, not
right.
just the back.
And what we say first is talking about the beginning.
Gotcha. So down, then up. So the graph starts down, but then finishes up.
Correct. Here's another example. Again, we're going to identify our leading coefficient. This time it is negative. And then our degree, that's my exponent here. This is why it was negative. My degree is even. So if you think about that, negative means it goes down at the end. And even means does the same. So it's actually going to be down and down. Down, then down. So they're both down. And again, we know stuff's going on in between. You like my pictures?
They're great. All right. Well, a little bit of an odd lesson, but even so, we will see you tomorrow. Ta-ta for now.